One part just called the function, one part called the further function. Today we check some function topic. Most of these groups learned what is a function. Okay, check here. We just have a very short revision for function. Hello. Oh, he's starting Kristen very soon. This is Isabella from Kristen. Okay. We check the idea about function. Relations first. Relations in mathematics, if we focus on the numbers, you have this type. That's a set. We can say D. This is R. You got 1, 2, 3. You got 4, 5, 6. Yeah, this is one type. And this is D. This is R. You got 1, 2, 3, 4, 5, maybe just 4 here. And you got D and R. 1, 4, 5, 6. And you got D and R. 1, 2, 3, 4. 1, 2, 3, 2, 4. 2, 2, 3, 2, 4. So that's like some relation, some relations. This one really gave you 4 types of relations. 4 types of relations. Can I know your name? Hi, Sam. Who is Hi, Sam? Oh, okay. Hi, Sam. Okay. This is called 1 to 1. This is called 1 to 1. Or sometimes we just say 1, 1. 1 to 1. Or just 1, 1. Because 1 value on the left related to 1 value on the left. This is called 1 to 1. Okay. D is called, the second one is called many to 1. This is called 1 to many. This is called many to many. Oh, so you just hear
12%.
听吗? Do you?
Yeah.
Oh, okay.
Yeah.
Yeah, same. Okay. Inside these 4 cases, Eden, 2 cases are function. Which 2? Two cases are function.
Is it the first one?
Oh yeah, it is function. Isabella, what's the other one? Okay, yeah. Many to 1 is a function. This one not a function. Not function. These two not function, huh? Not function. How we sketch each case in XY coordinate system. This is case 1. 1, 2, 3, 4. How we sketch it in XY graph or XY coordinate system. This topic graph in NCAA level 2 and IB standard level. Kristen learned functions last year. Okay, if you sketch the first graph in XY coordinate or Cartesian coordinate system, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, what point do we have? We have 1, 4, 2, 5, 3, 6. That's the graph for the first one. Guys, use the same idea. Sketch second, third, and fourth. How we sketch the second one? 1. 1, 2, 3. 1, 2, 3, 4. Isabel, how you sketch the second one? 1, 4. 1, 4 here, 2, 4 here, 3, 4 here. You don't need to connect it all. You don't need to connect. And next one. Yeah, it's roughly here, here, here. X1. 1, 4, 1, 5, 1, 6. And the last one. 1, 3, 1, 4. 1, 3, 1, 4. 2, 3, 2, 4. Okay? Okay. For function, we always use some idea called the vertical line test. If we check if it's a function, we use vertical line test. For example, if you sketch vertical line, you have only one possible intersection, yes, function. Only one intersection, yes, function. Oh, you got 3 intersection, not function. You can also say cannot pass vertical line test. Vertical line test. Oh, here, all two intersections cannot pass vertical line test. So not a function. Not a function. Okay. Hey, did you learn this last year? Yeah, good. Now let's check higher level book function. Of course, in functions, you guys learn something called inverse. You learn inverse function, composite function. You remember composite function?
No.
Hey, from Saturday group. FG, or from IG.
Yes. Oh, yes.
Yeah, FOG, you learn. Okay. A. For the first two functions, what's the domain? For the first one, what's the domain? Eden.
I said 1, 2, 3.
Yes, that's why I use D. This is called the domain. The possible input. Range is possible values of output. Okay? Yeah. So domain range, just some idea you guys learned. Okay. Yeah. Our group people know those ideas already. That's why we jump to revision questions. Other one, just revision. What's the domain? What's the range? If it's a function. If it's a function. We just said vertical line test. You just sketch vertical lines. Only one intersection. So yes, it is function. It is function. Vertical line test. Emma, how about the second one?
Not a function.
No, cannot pass vertical line test. Edward, how about C? Only one intersection. Yes, it is function. It is function. And for little part A, it is 1-to-1. 1-to-1. They didn't ask you. 1-to-1. This is many-to-1. Many-to-1. Why is called many-to-1? You can have a look. Any y value here. Any y value here. We got 1, 2, 3, 4 x values. They are x values relate to one y value. So many-to-1. Okay. So domain and range, just about possible input. For a domain, just x all real number. Yeah, from here, domain, x can be any value, so all real number. Or you can just say D, same as R. Oh, this R is a real number, not a range. The range here, the first one, range, y bigger than -4. The whole y value above -4. The last one, the range, Y value always between two values, 5 and -5. Okay? Five and -5. Easy? Homework, because just substitution. This one is 2 times 2 minus 2 squared, 0. Homework. Homework. This one revise some basic simultaneous equation. They ask you technology means calculator for graph. Calculator for graph. This question is about domain and range. With what value x, fx undefined, Eden, x equals what?
Is it square root of
No. 0. Because denominator cannot be 0. X equals 0, fx undefined. That's why we say domain x cannot be 0. For full work, you can write x just in R, but x cannot be 0. That's domain. Okay. Range. They ask you sketch using technology. For higher level student, we need to do it without calculator. At least you know one method. How we sketch graph without calculator. You can make a table, find some values, right? For example, x, y. fx the same as y. Or if x, we just check several values. If x equals half, 1, 2, how about y? Or if you need more values, -half. If you need an x like a -half, yeah, that's a basic idea for graphing. -half, -1, -2, how we sketch the graph. Okay. Okay. Isabella, values for y. Continue. 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 9. Okay. Yes. So we can sketch the graph already. Okay. Let's check the graph. Oh, it's all below. Below x-axis. Half give you -8. 1, -2, 2, 2, negative half. So the graph like this. After you finish something, this is a graph. 2 pieces, 2 pieces. Okay. This is the graph. Based on the graph, we know the range. Eden, what's the range? It's about YR. Y always
Smaller than 0.
very good. Y real number. Katrina, any question?
No.
Cool. Okay. Homework. 5 just substitution. So homework. Number 6, domain and range. We need to check all 3. Very typical. Very typical. Domain and range. For this type of question, you can just sketch the graph roughly. Sketch the graph. How we sketch the graph? For the first one, for domain, you know the domain already. X always bigger than equal to -4. I'm a y, x need a bigger than equal to -4. Right. So the first step actually inside the square root, you need a bigger than equal to 0. That's why x bigger than equal to -4. Now, if you just try some values, x -4, 0, 5, y just 0, 2, 3. So the graph just like this. Based on here, the range y bigger than equal to 0. Oh, we always imagine the graph or sketch the graph, answer the question. Edward, for B and C, what's the domain? Like any condition on X? No condition, you're right. X can be any real number. X can be any real number. Yeah, sometimes you just write domain, just real number. You can write domain, just R. Or you write X in R, like this. Or you write a lot of symbol, X line, X R. They're all the same thing. All means domain, real number. Real number. R with a line just means a different fonts. Okay. Range, a little bit different. Isabella, for part B, what's the range? This is a parabola. Do you know what the graph look like? Very good. Isabella said the graph is just this way. Or just this way. Yes, y less than equal to 1, y real number. Okay, Okay. Yeah. Part C. We need what's the first step? Eden, what's the first step?
Y equals 2x minus 1.
Oh, you factorize it.
Yeah.
Oh, x minus 1 like that?
Yeah.
Okay. Okay, can you make another form? What's the other form?
3 over 2. Oh, 2 and then x minus 3 over 2.
Oh, you mean step by step? Okay, we do step by step. Y equals 2 x squared minus 3 over 2x plus 1. 2 x minus what square minus what square plus 1.
X minus 3 over 4.
Very good. 3 over 4. Here, 3 over 4. Edward, what's the name for this working? Completing square. Yeah. So 2 x minus 3 over 4 square minus 2 times 9 over 16 plus 1. 1 over 8. Double check if it's 1 over 8. Isabella got 1 over 8? No, this graph look like here. Emma, how about the range?
Is bigger than negative 1 over 8.
Very good. Y bigger than equal to negative 1 over 8. Y real number. Okay? Okay. The idea. That's like a domain, the range, very typical one. Parabola. Parabola. Okay. Move on. Now the one we just tried is called parabola. This is a parabola. This is a parabola. This one is a sideways parabola, but just half a piece sideways parabola. Okay. This one is called Isabella. Yes, we learned hyperbola last year. Hyperbola. They ask you to find the equation. Hyperbola. These cases, just x, y asymptotes. We just write y equals a over x. Y equals a over x. Guys, try to calculate the little a. Calculate little a so you know the equation. Okay,
Excuse me, Dr. Zhang.
Eden, what's the first one? A. Good. Edward, second one, A. Good. Yes. Okay.
Dr. Zhang,
Yeah.
can you send the sheets to the chat as well?
Okay.
Because I still can't download from WeChat.
Okay.
Thank you.
No problem. Sending you this one last year stuff, asymptotes for hyperbola. Did you learn this? Isabel, answer the question. x equals for a. Okay, positive 2. For this is vertical asymptote. Vertical asymptote. For vertical asymptote, denominator equals 0. That's for vertical asymptote. Denominator equals 0. You got vertical asymptote. Okay. How about horizontal asymptote? We need x to infinity and check y equals what? If x infinity, what is y? That's why for vertical, we got x equals 0. For horizontal, if x very, very big, this symbol for function are same as y equals fx equals 4x plus 1 over 2 minus x. This is the symbol. If x infinity very big, how about y? Isabella? Very good. It's like 4 million divided by negative million. So negative 4. 1 and 2 can be ignored. It's too small. It's too small. Okay. So that's asymptote. X equals 2. X equals 2. Okay. We can sketch the graph already. We try E first. X equals 2 is a vertical one. Here. X equals 2. Y equals negative 4. Horizontal one. Here. So that's how we sketch these two. We say these two asymptotes. Okay? Asymptotes. X equals 2. Y equals negative 4. How we sketch the graph? We need to find x-intercept, y-intercept. That will be part D. For y-intercept, you need to make x equals 0. Eden, what's y-intercept? Eden, what's y-intercept?
Half.
Yep, half. So x equals 0, y just half, so which is a point here. Edward, if y equals 0, what's x? If y is 0, what's x? Edward. Oh, this function, check here. This is y equals if y equals 0, you got 0 equals 4x plus 1 over 2 minus x. What's x? What's x? Yeah, Jason. This division equals 0. That means numerator equals 0. Denominator cannot be 0. So x equals negative quarter. We got a point here, a tiny point here. Okay. So the graph just because it's asymptote, which means approaching here, approaching. Yeah, symmetrical. The other side just approaching this. Two pieces. Two pieces. Approach. Okay, approaching. So that's the graph. After you determine one piece, you know the other piece. That's part D. We finished E and D. They ask you sketch diagram function of the function. What's the meaning of sign diagram? What's the meaning of sign diagram? Let's check what's the meaning of sign diagram. For this function here, we are checking sign diagram. For sign diagram, check we have this is negative a quarter here. Negative quarter. On the left of negative quarter, it's below y-axis. It's negative. Or change to positive. This part change to positive. Between negative quarter and 2. For x value between negative quarter and 2, it change to positive. Isabella, how about after 2? Larger than 2. The graph again below the axis. So change it to negative. This is called the sign diagram. Isabella, what's your question? Like on this side, on the left of negative quarter, the whole graph below, so negative. And then between this part is above. After, below. So negative, positive, negative. I do a y on 2, I sketch a dotted line. Because it's asymptote. Asymptote, okay? We just try to use sign diagram to show more information. At 2 is asymptote. Okay. Okay. Domain and range. Isabella, part B. Hence discuss the behavior of the function as it approaches its asymptotes. You can say this part approach asymptote is getting higher and higher, or you can say increases, always positive, and increase approach the asymptote of x equals 2. Okay. But from this part, it also approaches, but it's getting negative. Smaller and smaller approach this asymptote. Okay, just sketch graph. Okay. The domain just x cannot be 2, but x is a real number. Hey, what's the range, Emma?
Y cannot be negative.
Very good. Real number. Okay. This is question 8. Question 8. Hey, there's a very good question. This is a higher level. 11. This composite function homework. Oh, do we need to do it? No, homework. We are doing this one now. This one is a little bit hard. Domain and the range. Domain and the range of composite function. You guys have a try first on number 11. It's a hard one. Number 11 is a hard one. Yo, check on. I will write 2 sentences. You double check if you understand. as the input of G. Inside here, who is the input of G? What's the meaning of FOGX? FOGX means FOGX just means FGX composite function. What's the meaning of FGX? You just substitute value into G, into the X inside the G, and you got the answer. Substitute that answer into F. For example, FOG form. Eden, what's FOG form? We need to calculate the G4.
Square root of 15.
Yeah. What's the G4?
It's 13.
Yeah. 4 squared minus 3. So F is 13. That means you substitute 4 into this. After you got the answer 13, you substitute into the F function. Square root of 15. You guys understand this? So, which means you got X, you substitute into G. After you got the result, you substitute into F. Okay? Okay, that's it. That's the idea about composite function. Input X into G, answer output into F, and you got the final output. Okay, so FOGX, the input of G is X. Okay, you substitute X into G. The input of F is GX. Double check if you understand these two sentences. This one really, these two sentences really just describe. You put X into G, and then result is GX into F. Okay? Check if you understand this. Or you can check this one. FOG, just same as FG. You just substitute the whole G into F. This one, this is the input of F. You just substitute this one into here. So that's the input of F. So the input of F is the whole GX. Now, let's check condition. Input of G here, no condition, any value. Okay? So X need just real number, no condition. What's the condition here, Isabella? Here. X must be bigger than equal to, X must be bigger than equal to, yes. So this input need the bigger than equal to -2. But this input is G, bigger than equal to -2. Okay?
Dr. Sam,
Yep.
so is fx is the same meaning as gx, but just different letters?
Oh yeah, they all function. Just gave you a rule. You need to do substitution.
Okay, thank you.
Like for this question just fx equals square root of x plus 2, which means f7 just equals 3. f14 just equals 4. So just like the rule.
Thank you.
But after you got this, We got gx, which means, what's that? This question really important. This 11 really important. That means x squared bigger than equal to 1. Isabella solved x squared bigger than equal to 1.
X is greater or equal to square root.
Oh, we really need this. If you need x squared bigger than 1, x could be 2 or minus 2. Minus 2 squared also bigger than 1. That's why if you need x squared bigger than 1, x bigger than 1 or less than negative 1. Oh, let's check again. X squared bigger than equal to 1, same as x squared minus 1 bigger than equal to 0, same as x plus 1, x minus 1 bigger than equal to 0. This graph look like here. Which part give you bigger than equal to 0? Here and here. This part is x bigger than equal to 1. This part is x less than equal to -1. Okay? The first condition doesn't matter. No condition kinda. That's why the final answer, x bigger than equal to 1 or x less than equal to -1. Domain. Check on domain. Yeah, this question actually pretty nice because we only have one part you need to solve. This part, the answer just all real number. You don't need to worry about it. We just solve the second part. Okay, how about the range? How about the range? Okay. Because this gx always bigger than or equal to -2. Based on here, the overall range just bigger than or equal to 0. For range, just bigger than or equal to 0. We need to check. We need to check again. Why the range always bigger than or equal to 0? Reason: f of g same as root g plus 2. G. F of g, you can say gx plus 2. I just ignore the x. Do you understand? This is gx plus 2. We are still checking this. F of g just same as fg. But f means square root. So g plus 2. Okay? Normally, this square root thing is bigger than or equal to 0. You cannot have a negative value. In this question, gx can give you -2, so it can reach 0. Okay, so that's why bigger than or equal to 0. Or you can change it to square root of x squared minus 1. This part always bigger than or equal to 0. Because it's square root. Yeah, we can sketch, use a calculator. sketch square root of x squared minus 1. Let's check the graph. Let's try to sketch the graph. We try to sketch f of g. Y equals sqrt x squared minus 1. Always bigger than equal to 0. And for x value, either bigger than equal to 1 or smaller or equal to -1. That's the graph. F of g. G of f. G of f like g fx. If you need to substitute x into f, x need to bigger than equal to -2. That's it. For g, there's no condition. So that's the domain. That's the domain. G of f. How about the range? G of f just same as f squared minus 3. G of f, because gx equals x squared minus 3. So gf just f squared minus 3. But f is bigger than equal to 0. Bigger than equal to -3. Okay, it's something squared minus 3, so bigger than equal to -3. That's why the range is bigger than equal to -3. Why? This one too hard. You need to think about it again. Why bigger than equal to -3? Of course, we can sketch the graph. Have a look. Anytime, if you start, you just check calculator. How we sketch it? It's g. So which means something, the whole thing squared minus 3. What is inside? It's f, which is sqrt, x plus 2. Yeah. What's the domain? X always bigger than equal to -2. And the y value always bigger than equal to -3. Okay.
Why can't it just be a straight line?
Oh, because after you simplify, you find just x minus 1?
Yeah.
Okay, let's check here. Very good question. Very good question. First, we need to send this one to WeChat group, and then we erase it. Okay. Yeah, Isabella asked a very important question. Very important question. Okay. We are checking part B. This idea higher level only, not in standard. We check part B. If you just simplified just g fx, which is g square root of x plus 2, which is square root of x plus 2, squared minus 3, which is x plus 2 minus 3, which is x minus 1. Okay. Hey, here, very important idea. When you write this part, what's the condition on x, Isabella?
It's greater than negative.
Yes. So you need to keep this condition. That's why when you sketch x minus 1, you got this line, whole line, right? But you need to remind yourself, this x need bigger than equal to -2. So we need only this piece. Okay, we need only this piece. Okay. Understand this one? We have an actual question. Question 11.5. I just designed a question. Hx equals x over x. How you sketch the graph? Hx equals x over x. How you sketch the graph? Okay, Edward just said, is it just this one? Why this one not perfect? Emma. Right. So the real answer should be a hollow circle here, and then because when we simplify, we need to remind ourselves what's the condition on x. You have x over x, x cannot be 0. 1. The whole thing equals 1, but the x cannot be 0. That's why we have a hollow circle. Okay, almost a horizontal line. We have a circle there. Okay, this idea is similar. After you simplify it, you might ignore the original condition. Okay. We need to check very beginning. We have the condition there. Edward, understand this idea? Yes. Oh, this type of idea very popular in AP. You check some AP questions? Not yet?
And level 3.
Oh, level 3 is about the,
Yeah.
like here, jump, continuous, or yeah.
Can we see it as AP?
Oh, you can do by yourself. Because AP, like standard exam, everybody can do it. Not like IB. You can only do IB in school. Okay. Okay. That's 11. Oh, inverse function. We double check one question. Inverse function. Okay. Number 12. I can tell what's the meaning of inverse function. This one same as 3 equals f4. Inverse function. Oh, Michael asked, why isn't the domain of G also restricted by the range of f? Oh, there's no condition on G. Because for G, x can be any real number. Any real number. So when you substitute into G, the domain of G restricted by. Michael, you're asking A or B? Oh, B, okay. We check B again, guys. More here. For example, we try B again for domain. X is the input of f. That's why x is bigger than equal to -2. Fx is input of G. No condition on f because G input any real number. Okay, there's two conditions. The second one, no condition. Oh yeah, you're right. Michael actually asked a good question. Yeah, that's why. This one, GF equals f squared minus 3. This f always bigger than to 0, so the whole thing bigger than to -3. We got it, bigger than to -3. Okay, Number 12 is about simultaneous equation. F2 equals 1, just the same as 1 equals 2a plus b. F4 equals 3, just same as 3 equals 4a plus b. Eden, what's a? What's b? Yeah. For the domain, the range of composite function, we will double check again when we try more functions. So today, just one example.
B is negative 1.
How about a?
A is 1.
A is 1. Yes, A is 1. What's B?
Negative 1.
Yes. Isabella, the same? Okay. Let's do 2 easy questions. Inverse for 14 and 15. That's like a revision. Yeah, this is simple inverse function, same as last year. Yeah, the idea just rearranging y equals x equals 4y plus 2 is really basic. Y equals x minus 2 over 4. F inverse x equals x minus 2 over 4. Second one, F inverse equals 3 minus 4x over 5. Isabella got the same answer? Yeah. Just rearrange. Part A, sketch inverse function. How we sketch inverse function?
Just swap the x and y.
Oh yeah, swap x, y. This one is 1 and negative half. That means you got negative half and 1. This point. It's also something reflection about this line. If you swap x, y, it's a reflection about this line. Reflection. 2, negative 2. -2 and 2. This point. Just reflection on reflection. Past this point. Why my one look different? Oh, I sketched a wrong point. -12 and 1 is here. That's why my one look different. Roughly. Reflection. The range. Range of F inverse. The range from the graph is easy. Y just between 2 and 0. Okay. Okay. Fx equals this one just means -3/2 equals -half x squared. Isabella, what's x? E? Really? X squared equals 3. X equals √3 or -√3.
Substituted that into x as x.
Oh, that's y value. The answer is here. You need to reject this. Eden, why we reject it? Reject the -1. X is 0 to 2. We have conditions. That's higher level. F inverse x equals 1. Same as x equals F1. -half. Okay. -half. Or we can read the graph. We can read the graph. For Fx, guys, we try to read the graph. Fx is the blue one here. They gave you y value negative 1.5, which is here. They ask you what's this value? Around 1.7. Inverse gave you output 1. That will be this point, negative half. You can either read the graph or check the formula. Okay? Yeah. Now. Yeah. 16, higher level only. The symbol just means fx equals 3x plus 6. Hx equals x over 3. This question. Oh, it's about F inverse, H inverse. You need to find both. They ask you show. That means you need to simplify the left-hand side, but a lot of working. First, you need to find H inverse, which is 3x. You need to find F inverse, which is x minus 6 over 3. like rearranging. You need to find F inverse OH inverse. That means you substitute H inverse into F inverse. 3x minus 6 over 3, which is x minus 2. That's the left-hand side. For the right-hand side, HOF equals, you substitute the whole F into H. 3x plus 6 over 3, which is x plus 2. Now, we need to find the inverse of this. Oh, inverse just x minus 2. Function x plus 2, inverse just x minus 2. Therefore, left-hand side and right-hand side are equal. This is 16. If you are not sure, because something too young, if you are not sure how I got from here to here, message me after class. I will send you some video about this, how we find the inverse function. Okay. Part B. Self-inverse. Oh, which means after you find the inverse, you got the same thing. This is again higher level only. If you sketch a graph, the graph, yeah, later we use algebra first. Use algebra find the inverse function. Like y equals 5x minus 1, x minus 5. Rearrange. X equals 5, y minus 1, y minus 5. Find y. Find y. For inverse function, you swap x, y, and find y. After you rearrange the same, still 5x minus 1 over x minus 5. So this is called self-inverse. Your inverse still the same form. On the graph, because inverse and original function is about reflection about y equals x, which means this graph should be around like this. They're really just symmetrical about y equals x. Okay, so self-inverse, if we sketch it using technology, they really just reflection itself, reflection about y equals x. Y equals 5x minus 1, x minus 5. Yeah, check here. If you sketch y equals x, itself already reflection about y equals x. That's why it's called the self-inverse. Okay. You need to do homework all before. We don't have much homework. All up to here, question 1 to question 19. Answer is in the last page. If possible, we can try some 15b. Next week, we check some higher level idea in 15b. Okay. Answer. Oh, what? I made a mistake. These 2 pages same. Oh. You got the same pages? Oh, so less homework. Okay. Yeah. Okay. Take care, guys. Try the homework. Answer in the last several pages.